I'm doing a last push for one of my classes. Hi there, this is Big Spruce Rabbitry, and there's not going to be a huge number of public videos until March because I will be teaching for the University of Alaska Fairbanks' Summer Sessions SMART Academy for homeschoolers, where we're doing STEM classes for kids. So I kind of want to just talk a little bit about this and say how it's an opportunity for you even if you don't live here in Alaska. So I'm teaching a class called the Metric System for Junior Scientists. This class is designed to teach you both the metric system and a whole bunch of measurement tools that you'll use in every science class going forward. Learning the metric system is a lot like learning a musical instrument. It takes a lot of practice and discipline to get good at it, and it also can be used in a lot of unusual ways, which is often skipped over in a curriculum, making it not really seem as important as it actually is. The metric system was developed during the French Revolution as a perfect measurement system. Now, it's not perfect, but it is very useful, and I will take you through examples from biology, physics, chemistry, and in your daily life of where you use the metric system and why it's so useful and important to learn. So definitely check out that class, and we're going to go and do a problem. Okay, we're back in the house and we're going to do a unit conversion problem to show you kind of the usefulness of the metric system. Okay, so our problem is, what is a milestone? Well, this is a weird English unit for force. And a force is a push or a pull, so I went ahead and I drew a rock here, and the red line here would be a push on the rock, so a force. So a milestone is a way you could measure the amount of force that you're pushing on this rock with. Well, milestones are a really weird unit, and it's going to take us a little bit to turn this into the metric unit for force called a Newton. So let's do that. To be able to change this weird unit of milestones into the unit of newtons, we first need to define what a newton is. A newton is a kilogram times meter per second squared. The first thing that we'll want to do is turn those miles into meters, but the stones are actually already a measure of force. It's a measure of weight, the amount that gravity is holding you to the ground. This is one of the big problems with the English system, is that both pounds and stones and other English units are all measurements of weight, and it makes doing physics with these units a lot harder than doing it with newtons, where the mass is already separated out. And bonus point to anyone who can tell me what the English measurement for mass is. We need to look up the conversions to take these English units into metric. With these conversions, we're now going to set up a conversion table. We have 1 milestone, and what we eventually want to get out here is a kilogram meter per second squared. So we're going to want to first cancel out the miles. So I'm going to convert this milestone into foot-pounds first. So at this point, we would multiply across the top and divide by the bottom and be able to get a number of foot-pounds, which is a more common English unit for measuring force in. Well, we don't have to stop there, though. I want to go straight to newtons. So I've got my unit conversion table set up. I'm going to want to go through and cancel out units. So miles are going to go away. Feet are going to go away. Now remember that we're here on Earth, so a kilogram and a pound we can just interchange the way I did here, but a kilogram is a measurement of mass and a pound is a measurement of weight. And a pound comes with it an acceleration of gravity, which is one of the big problems with us using it as a base unit in the English system. So we've went through and canceled out all the units that we don't want and are left with kilograms and meters. Now this doesn't really look like a Newton because it doesn't have a per second squared, but it does actually because we converted pounds, which are a measurement of weight, which is a force, to a kilogram, which is a measurement of mass. This conversion isn't entirely correct because you have to be on the surface of Earth for it to be true. So that actually means that when we did this conversion, we ended up getting that meters per second squared term, but we just kind of ignore writing this because it makes it a lot more complicated to write it. And we just know that if we're here on Earth, then this is going to actually turn out being a Newton. So a kilogram meter per second squared. So let's math out these numbers and see how many newtons a milestone is. So we multiply along the top and then divide by the bottom. So we've got 49,580 newtons in one milestone. If I wanted to write milestones in kilonewtons, I could pretty quickly do it because the metric system is base 10. All I would have to do is put a K here for kilo and move the decimal place over 3. And that's done, no table required. So, hope this gives you a sense of why the metric system is awesome. The name metric system for the junior scientists might not sound as exciting as outer space physics or chickenology, but I can assure you that the metric system class is going to be one of the most cool and useful classes you could take as a homeschooler, so please check out that class. It will be a lot of fun.